Yeah, they're my kids. Thank you. They're a little older now, but you know what? I will show you my cute kids on video. Um, where is it? All right, so this is how far they've grown. Am I really doing this? Yes, I'm doing this because they're so cute. Start video. So this is my number 3. Yes, all louder. Okay, and these are my 2. That's how big they are now. Oh, that's right. That's right. I'm not biased. They are the cutest kids in the world. Okay, so yes. Yes. Envy me for having such cute kids. All right. Anyways. Yeah. But my share of problems will come later. I have it in mind to follow my brother-in-law's footsteps, learn my jujitsu, and learn how to wield a weapon, whatever I need to, because they're gonna grow up and start bringing people home. You know what I'm saying? Gotta be that dad. You know what I mean? Yeah, I got no choice. Okay, I gotta make sure to protect my family. My family's my family until they get married. Then they're my family too. But family's family. I don't care how old-fashioned that is. The way I am. All right. This is my grade 9, so you don't have to see anything. I have it in mind to finish off our remainder part 1 and take up any questions you have, especially from, let's say, question 2. And then we will continue on and finish this idea of the remainder theorem by showing you a second shortcut. Because yesterday, our remainder theorem shortcut only helped us find what first? It's in the name. What did it help us find first? The shortcut. Yep. The remainder. What if you want to know the quotient? Well, there's this thing called synthetic division. By synthetic, it means human-made. It was made by a person, just invented, to help make the division faster. And I think majority of you, I really mean it, majority of you, I think, will appreciate synthetic division more because it's so quick. But I need you to know both, at least for our quiz and test. After chapter 2, you can do whatever you want. But up until chapter 2, I need to test to make sure you know both of these. Okay? And the long division you might appreciate if you do go towards the math route in your higher order education, because there are other theorems and methods and techniques that use elements of the long division to solve it. So it's good to know. Okay? So here we go. Any questions from the homework? Yep. Go over data system. Correct. Okay, so it's right here. Let's do it. Using a blank, let me clear this. The question was, I have with me where is the question? Okay, so I have a function. We'll call it p of x. It happens to have a leading coefficient as k. So it's a mystery. I don't know what that number is, but we'll figure it out. It is being divided by the divisor x plus 1. The remainder, I'm going to just call it Rx, the remainder happens to be a 7. That tells us a lot more than you might think. This means that here, if I plug in x equals -1, which is the root of that divisor, the answer is going to be a 7. That's what this means. Another way you can interpret this is if x equals -1, my y is a 7. That's what the remainder theorem is. It's just literally plugging in a number. Take a look. If I plug in a -1, it is going to equal 7. That's what the remainder theorem tells me, which means k times -1 cubed plus 5 times -1 squared minus 2 times a -1 plus a 3 equals 7. So -k plus 5 plus 2 plus 3 equals 7. -k plus a 10 equals a 7. So the only way we can make this work, -10 minus 10, the only way we can have a remainder of 7 is if the leading coefficient is a positive. Mystery solved. But only if you understand how to use the pieces that were given. And remainder theorem means if we take and plug in the root of our divisor, equals. We'll get more exposure today. So if you're still like maybe about 50, 60, 70%, it's not a bad place to be. Any questions? Mm-hmm.
Can we go over the restrictions for number 3?
Oh, for number 3? Sure. Number 3 states, write a division statement for the calculation below. So the question was about the restriction. Allow me to simply erase this first and answer the question quickly. The division statement is not the quotient statement. That means 6x3 minus 9x squared plus 2x minus 5 is equal to the divisor times the quotient plus the remainder. That would be my division statement. My restriction, because I am dividing by something, I need to make sure that can't be a 0. Because I am dividing by 3x squared minus 3, this can't be a 0. Let me divide both sides by, actually, that means 3x squared cannot be equal to a positive 3. And divide both sides by 3. That means x squared cannot be equal to a 1. Which means x cannot be plus 1 or a minus 1. Those are my restrictions. As a rule of thumb, just you can't divide by 0. Rule of thumb. Okay. There might be some other things that we twist and turn as you travel through your math journey, but right now, just don't divide by 0. Okay. Other questions? These are good, everyone. Shows me you're trying. Yeah. If I wrote x can equal 1, so if you got to here but only wrote 1, yes, a -1 is a valid actual, existing number. So probably like depends on how many marks it is, but I would imagine it's a half mark. Yeah. A question like that, 1 mark for the division statement, 1 mark to solve for the restriction. Yeah, that'd be half for sure. Okay. All right. My hope and my expectation of my class was to have been very annoyed by long division. So if you did get a chance to try some of the questions from the textbook printout, awesome. I'm hoping you had a chance to, again, as I keep saying this, get annoyed by the long division so that you will appreciate today's method. Here we go. Part 2 of today's lesson is synthetic division. I have copied the same equations, the same functions from part 1. Okay, so this is same f of x and g of x, okay? Just to remind you. And you're going to divide. But instead of doing long division, what's beautiful about synthetic division is as long as you write everything in numerical order according to degree, you don't have to worry about the degrees. You only have to look at the coefficients. So let me highlight the numbers for you. Yes. Yes, I can do that. That better? Don't worry about it. Okay, so actually, let me do this. The coefficient of the largest degree is 1. The coefficient is 4. The coefficient is -1. The coefficient is -16. And then the constant term is -14. In chronological order, I am simply putting them down. Just the coefficients. And with this cross, this little line, place to the left the root. You are going to do some multiplication and some addition. Are you ready? Step 1, on the right side, you see me writing out all the steps, but I think it's better that I show you instead of reading it. Ready? The very first coefficient, just drop down. I need a number to work with. Next, take the root. You're going to multiply with the number in the bottom and write right here. Oh, is there a way I can highlight this? Opacity at 50. We'll use red and make it nice, big and bold. Like that. Okay, -1 times a 1 is -1. Add down. What is 4 plus a -1? And repeat. Take your root, -1, and multiply and write next. What is -1 times 3? Negative. And then add it. -1 times -3 is -4. Next. What is -1 times -4? I wish they had a preset. Changing this every single time is very annoying. 4. And then add down. 12. And then -1 times -12. Whoa. -1 times -12 is +12. When you add it, you get -2. What do these numbers tell you? Well, these numbers, the coefficients of the quotient from constant term. Okay, this is my remainder. What do I mean by that? It means f of x divided by g of x is equal to, everyone look at, I'm going to wait for you because I'm going to show you. Negative 12 is the constant term. Negative 4 is x to the power of 1. 3 is x to the power of 2. And 1 is x to the power of 3. It increases from right to left. And we have my remainder. In case you're wondering where the x plus 1 came from, that's my g of x, right? So this is technically x plus 1. That's my g of x. And if you're wondering, take a look at your part 1, the front page of part 1, and compare your answer. It's the exact same. Compare what we have here with your answer from part 1. You get the same answer. So your choice. From chapter 3 on, long division or synthetic division? You choose. But we were able to do this very quickly. And I'll demonstrate again. Once again, it only works, just like remainder theorem, it only works when you have a binomial, because you need a root here. It only works, I'll say it one more time, it only works if you have a binomial. Okay, how about I put it here? Synthetic, only if g of x equals ax minus b, okay? A binomial. Just like remainder theorem. Okay, and so we have example 2. Could you take a look at this as an example and try to at least map out set up the synthetic division? You don't have to perform it, but example 2, I have with me the quotient, sorry, the dividend and a divisor. Using just this, ignore that. Using just this part of the question, would you please set up the synthetic, and we're going to perform it together and check if this is correct or not. Okay, using synthetic division, confirm if the following equation is correct. So I will zoom in. This is the dividend. Very. This part is the dividend. This is the divisor. Figure out which coefficients you have to use, what the root is, and try to set up your t or your cross. Yep. What numbers are going in here? And what numbers are going in there? I'll give you another 10 seconds. Figure out what numbers you put in. Sorry, was that a hand? Go for it. Uh-huh. Uh-huh. -2. That's it. And what is on the top left? Awesome. Mm-hmm. Excellent. That's half the battle. Let's follow the steps. Drop down the first number. We need something to work with. 2 times 1, 2. So you add it. 2 times 5, 10th. You add it. 2 times 8, 16. What does that mean? It means this is my quotient, and that's my remainder. Therefore, when I have f of x divided by x minus 2, my answer is, let's see, 8 first, that's my constant, plus 5 means it's with a single x, plus the 1 means it is the next term up, x squared. And my remainder, 15 over x minus 2. Am I correct? Maybe that's a typo. Okay. So it should be 15 over x minus 2. Yes, we have confirmed that this is incorrect. So you mean in your answer or in the actual question? Yes, just like before, if you have a x term, so it's like 3, 2, 1, and 0. If one of these numbers were missing, you need a placeholder, just like division, long division. And everyone, that's it. Synthetic or long division, and put that together with remainder theorem. And of course, you know where we're going. My hope with this, right? Every time I do this, I'm like, I really hope the remainder is a 0, because that would be really nice. That's where we want to go. But for now, we need to make sure we can divide at the drop of a hat. Question? Good observation, absolutely. Because we have x to the power of 3 dividing by 1. Inevitably, we have to have 1 degree less. So when you get your 1 by 8, you know the start. Yes, this one is remainder. The next one is constant. Always. That's why every. Yeah. That's essentially it. What I'm going to do as a challenge for you, if we can do this, what's left is just textbook homework. Take a look at the back sheet. That little graph, I couldn't find a good one online. I think I just took a sticky note and just put it there. I am going to get you to try this. These numbers are nicely fixed so that you will have a pleasant surprise, which will allow you to go the next step and merge with or marry your knowledge of chapter 1. Please divide. So 2x plus 3 is a factor of. Please use whatever division you want and then sketch the graph. Use everything you know. Sketch the most detailed graph you can, given your knowledge right now. Remember pasta. Remember y for x, and you said everything. Try it. So I'll give you, make an attempt. I'm going to limit this to 5 minutes, and I'm going to take it up to here. Give it an attempt. If you're frozen, put a little star saying, I didn't know what to do next. Right? Part of your studies is identifying where it was a hurdle for you. Yeah. Nice. What? Write it down. See what happens. Oh, hint. If you divide it out, write it as a division statement. I think it might be more helpful for you when you graph it to write it as a division statement. Let's fix up where it is. Couple more minutes. So write it as a division statement. All right. I see most people are making. Any preference, class consensus? Do you want long division or synthetic today from me? Who says long? Okay. Who says synthetic? You want to see it in action? Okay, we'll do synthetic today. If you're curious about the long, I'll show you after. Here we go. My coefficients are 2, -7, -3, 18. The root is -3/2. When you have a fraction like this, I think it's okay. Was there a trick to this that I forgot about? Oh, that's right. Oh, darn. Let me do it in long division first. If you did synthetic, because this was a fraction, I forgot to mention this. Because it's a little bit more complicated with the a value, something has to be done. It does make your life easier, but I need to mention it, okay? So just hold off for a sec. Let me do long division first. Okay, let's see. X squared gives me 2x cubed plus 3x squared. Subtract, I get -10x squared minus 3x. Here, I have to do -5. Ethan, you notice how it's half of what you had before when you did synthetic? Everything was half, right? There's a reason for that. And thank you for helping me catch it. It's my fault, not yours. X. So that is 0 and -3 plus 15. That's a 12x. And lastly, I need a plus 6. Notice how it's half of 12? Yeah. And yay, the remainder is a 0. What does that mean? That means my f of x is equal to 2x plus 3
multiplied by x squared minus 5x plus 6. And if you have a quadratic, you might recognize that you can go further. This is x minus 2, minus 3, and the zeros. So have this down. I'm going to do synthetic, and you'll be like, whoa, why is it different? It's because that binomial has an a value. You're going to have to separate this and do it in 2 different steps to make sense of it. It's my fault, not yours. Just be patient with me. So now that you have your zeros, you can also calculate your y-intercept. You can figure out your end behavior, and then you can graph it very accurately. For synthetic, you might be impatient and you say, okay, so what's the big deal? You know that, let's put it here, 2x plus 3, when it equals a 0, 2x must equal negative 3, and that means x must be negative 3 over 2. I would like you to separate negative 3 over 2 as negative 3 and 1 over 2, because you're multiplying, okay? Write your negative 3 here and put down your 1 over 2 here, or lower, much lower. Maybe even lower than that. Maybe down here. This is what I like to do. Okay. Same as before. The only difference is for here, you are still multiplying, but as you go through the half, I want you to also multiply that number. Okay? Would you prefer, remember, this is synthetic, so we can do whatever we want. Do you like to work with the half, or would you rather work with the denominator as a whole number? Just half is okay? Okay. Okay, so we're gonna, so no, as in, do you want to deal with multiply by 2 half, or do you want to deal with divided by a 2? What is easier for you to memorize? Just keep everything multiplication? I think so. Okay. All right, so let's do this then. Remember, if the root is negative 3 over 2, then you have a negative 3 multiplied by a half, right? Negative 3 on top and a half on the bottom. Here we go. Synthetic. Drop the 2 down. But I have to keep going. What is 2 times half? 1. Then you do what you normally did. You take that number, 3 times the 1 is what? Oh. 3 times the 1 is negative 3. Add it. That's a negative 10. Then multiply by half. Negative 5. And then when you multiply again, negative 3 times negative 5, positive 15. Add it. And multiply by half, 6. 6 times -3, positive 18. Sorry about that. Positive 18. Nope, negative 18. You add it, that's a 0. So even if I multiply by half, it's still just a 0. I hope you see why there was a concern. The answer is not 2, -10, and 12. It is a remainder of 0 and let's see, 2x plus 3 minus 3. Yeah, 2x plus 3, it is x squared minus 5x plus 6. It's very important that you separate that if you want to make sense of synthetic division. So if it's a regular binomial with the a value being 1, you stick it in the top. But if it happens to be a fraction, put the numerator on top as you normally would, set the denominator on the bottom, and your final answer is that second row. You might need a little bit more practice before you get the hang of synthetic. If you don't like it, just bear with it for the first quiz and test, and then you can just use long division for the rest of your life, I guess. Here we go. Continue on. I am going to go ahead and create this graph. If you want to try it by yourself, don't look up until you're ready. Let's see, the zeros are -1.5, 2 and 3. There's also y-intercept. If everything was a 0, 3, -9, positive 18. Goes way up here. This is odd, no second order, and the leading coefficient is positive. So it's going to be something like something like that. Practice today with homework questions. Wrap your head around this concept. Because if you can get this, you've officially stepped into the world of factoring any and all standard forms I give you. Okay? I can give you x to the power of 10, technically. You'll still be able, you still have the tools to break this apart. Question?
For example, we can just use minus.
True. In general, there are fractions will be a lot more efficient than decimals. Case in point, even something as simple as something to the power of 8, that looks nice and neat. That is 3 decimal places. It gets annoying. Or if you're an American, right, 1/16 of an inch, that is 0.0625. It gets very annoying. And so out of convenience, and mathematicians are lazy, fractions are always preferred. Yes?
But I got to, 9
A 9? I could be wrong. Let's see. As a y-intercept, I took this or that, whichever one, and I plugged in a 0. So that would be 0 plus 3 and 0 minus 0 plus 6. So that's 3 times 6. It's 18. Any other questions about this at least? Yep. The notation?
Yeah, like a square bracket and then.
Oh no, that's not a square bracket. That's just technology. It was just, yeah. So that's the point. That's the point 18. Y-intercept is 18. Okay, that's x and y. Yep.
Is that like in the original example, that last value is that unrelated?
It is related. Yeah. True. You know what? I have such a habit of plugging in 0 all the time. But if you have the blessing of being given a standard form, then you already know that's 0, 0, 0, and 18. You can look at that number. Absolutely right. It's not a habit for me. So good point. Anyone else? Okay, then as a reminder, your task, okay, all 2.1. We talked about long division, okay, both x minus b and ax minus b, or ax squared plus bx plus c. Like, it doesn't matter. You can do long division. We also talked about synthetic division, right? And that is only exclusive to binomials, right? We also talked about the remainder theorem and how that can be useful to shorten a question and not do all this long division if I don't have to. And of course, using remainder theorem for thinking / application questions that can be tricky. So here's where the amount of time you invest will really come in handy. Try to get as much exposure to different kinds of questions that try to screw you over a little bit by making it confusing. But once you find your way, you're like, oh, it's the same math. That's going to be one of your tasks, I guess, as we approach the weekend. Okay. Tomorrow, when we cover 2.2, we are going to ask ourselves a very important question of, what if Mr. Kim doesn't give you nice numbers? How do I know what is a factor? Like here, I said, hey, this is a factor. It is going to give you a remainder of 0. What if I don't give you that and I just say, sketch it? Are you stuck? The answer is no, you're not. We're going to look at what you can do to get out of that situation tomorrow. Okay? Try as many homework questions. Come tomorrow morning with questions and we'll try to address all of them. If there are no other things, then I'm going to turn off this video and stop.